Welcome to clickmyproject.com. Let us discuss about the miniaturized dual band and dual polarized antenna for MBAN applications. Let us discuss about the abstract of the product. As a recently prescribed a wireless communication technology allocated at the 2.36 to 2.4 GHz band, medical body area network, so that is a MBAN, has attracted and its enormous potential in monitoring and recording vital psychological parameters for medical and healthcare purposes. So, in this proposed work, present a novel miniature antenna with dual results covering the medical body area network, so that is a MBAN, and a 5.8 GHz, so that is a ISM band, so the industrial scientific medical band. Owing to its stacked patch structures, the proposed antenna generates an omnidirectional radiation pattern with vertical polarization and a broadside radiation pattern with circular polarization of the two bands respectively. This fulfills of the requirements for both on and off body channels simultaneously. This antenna is designed for multi-layer tissue model. So the footprint of the proposed antenna is only for the 0.18 lambda naught. So lambda naught is equal to C by F. So C is the free space velocity and F is the frequency. So that is a 5.8 GHz. The proposed design is fabricated and its performance is investigated in various scenarios. When measured on the port track impedance bandwidth of 2.8% at the lower band and 9% at the upper band are achieved, fully covering the two bands. Besides, the transmission performance at the MBAN band is also studied by conducting measurements on the human body, and the measurement results agree with the situation of simulation. So the written laws and bandwidth of the proposed antenna are calculated by using the MATLAB software. So finally, we calculate the robust antenna performance, reveals that the proposed design is suitable for the MBAN application, so that is a medical body area network applications. Let us discuss about the flow diagram of the product. So this is the overall flow diagram. First of all, design the antenna and calculating the parameters for the design, and then assign the center frequency, and then solving the RLC circuit, that is a resistance, inductance and capacitance circuits, and finally calculate the return loss and radiation pattern. Finally, performance analysis of the antenna design. So in the first system, so that is an antenna design. So in this design, so the upper patch is a corner truncated square patch feed directly by a probe, which is generated CP, so that is a waves of 5.8 GHz. The lower square patch is capacitively coupled fed by the probe through via hole. To excite the monopolar patch mode, that is a MBAN band, and this generate omnidirectional radiation pattern with the vertical polarization. The lower patch is shorted to the ground plane and 4 metallic pins for onboard application. Antennas with coaxial probes normal to the body surface will cause there is a result inconvenience and the discomfort. To solve this issue, the transition of feeding position to microstrip line is utilized the facility of soldering of the coaxial connector. So the upper patch of the microstrip line and ground plane are etched with the 1 mm thick of the FR4 substrate. So the calculating the parameter of the design, so the FR4 substrate is used, and the height is a 1 mm, and then epsilon r is equal to 4.4, and the tan del is equal to 0.02. So the lower patch is etched with the 2 mm thickness. So these are the calculating parameters for the design, and then assign the center frequency. So assign the center frequency, that is a 5.8 frequency, 5.8. So that is a MBAN band application. So the solving the RLC circuit, we can solve the R and L and C. So that is a parallelly connector. So R is the resistance and L is the inductance and C is the capacitance. Finally, we calculate the return loss and radiation pattern of the antenna. So the measured reflection coefficient of the fabricated antenna and the MBAN band both in free space and the on-port truncated. So and compared with the simulation results, the measured bandwidth in the free space reflection coefficient is less than minus 10 dB. Is the form of 2.385 to 2.445, and the prototype is mounted the port trunk. The measured bandwidth ranges from 2.3 to 2.4 GHz, which completely covers the 40 MHz bandwidth required for the MBAN application. So finally, we calculate the return loss of the dual band, and the radiation pattern is calculated in the E plane and H plane of the transmission. So the transmission performance of the proposed antenna in body propagation links and the MBAN band for studied at the two antennas with the outer's body. So that is the measured results of the calculating the plotted and the performance analysis. Finally, we calculated the return loss and radiation pattern of the cover. So finally the frequency is 5.8 GHz ISM band is presented attached to the on-body application. So finally calculate the performance analysis. So these are the overall flow diagram of the process. Let us discuss about the running procedure for the product. So click the title name, so and then run. So this is the panel panel box. So this is first of all the patch antenna and the characteristics. So in the patch antenna we define the frequency of in gigahertz and the electric constant in substrate. So thickness of the substrate in mils. So in the frequency gigahertz we type for example 5.8, so that is a center frequency, and then the dielectric constant we using the FR4 substrate, so the dielectric constant is 4.4, and then the thickness of the substrate is 1 mm. For example, that is a 1 mm. So 1 mm the mils is calculating by the, for example, the 1 mm is equal to 39.37 mils. So for example 2 mm is equal to 78.74 mils. So here we obtain 39.37 mils. So that is a 1 mm. So and then calculate. So we can calculate the length of the mm with the radiation resistance, efficiency, gain, and characteristic impedance of ohm. So these are all the characteristics are display, and then the radiation pattern and actually related between the return loss, that is also displayed in the product. Yeah, here this is the length of mm. So length of mm equal to 11.48. So that is the length of the patch, and the width is a 15.7392 mm. So that's the width of the patch, and the radiation resistance calculating in the ohm. So that is a 621 ohm, and the efficiency of the patch antenna is 0.854. So that is a 85.4%, and the gain of the antenna is a 13.073, and the characteristic impedance is 82.6. So these are the characteristics of the patch antenna, and then the radiation pattern of the plot of E and H plane patterns. So this the red is denoted the E plane and blue is denoted the H plane. So these are all the up to 360 degree of the calculator. Finally, and then we calculate the return loss of the patch antenna. Finally calculate the return loss of the product. So return loss is a 5.5 to up to 6.1. So the dual band frequency we achieve. So these are the different types of dual band we achieve the return loss. So return loss is AS11. Finally we calculate the frequency of gigahertz into 10 power 9. So the gigahertz is 10 power 9. So the length of the M, so that is 11.8, width and radiation resistance, efficiency, gain, and characteristic impedance. Finally calculate the return loss of the product. So the radiation pattern and return loss is kindly calculated by using for the patch antenna, that is truncated with a corner cut. If we give the none of the products, so all the values are none, and then there is a no radiation pattern and there is a no return loss we can. So these are the overall running procedure for the product. Thank you for listening this video.